We're going to be looking at the difference quotient today. It's our first look at derivatives. So let's dive in. We're going to start with a picture. So it's always good to start with pictures. So let's say we have some function f of x. I don't know, I'm making it however I want it. This is going to be f of x. That's this function. So let's take 2 points. This point, and we can pick a point down here. That sounds good. Okay, so if this is x, and let's say this is x plus something, I don't know how far we went, then the y value that goes with x would be considered f of x. And the y value for this point would actually be f of x plus h. If I play connect the dots, when I connect those dots, I can make a line. It's a horrible line, but it's a line. So if we took f of x plus h minus f of x over x plus h minus x, what is that representing? Well, that's representing the slope of the secant line. Now, how could this simplify? Well, x plus h minus x, that's really f of x plus h minus f of x over the x's would cancel and leave me with h. So h is the distance between x and x plus h. It's the difference in my x's. So what happens as we get this distance smaller and smaller and smaller? Well, our line's going to get, like, I can move it to there, I can move it to there, I can move it to there. As we take that distance and make it approach 0, let me write that mathematically, as h approaches 0, what happens to the secant line? Well, the secant line how can I word it? Eventually becomes what is called a tangent line. So if I got it super close, I'm actually getting it where we would just be looking at what is the slope right there. Tangent line touches at one point. So if we took this slope of the secant line, which I could rewrite like this, and, oh, sorry, my computer's making noises, and see what happens if we say the limit as h approaches 0. What we're finding is the slope of the tangent line formed when those 2 points become the same point. So when x comma f of x and x plus h, f of x plus h, become the same point. So we are able to find the slope at every itty-bitty little point on a graph. We don't always have to have 2 points, which will come in very handy. So let's look at an example. What if we have f of x as this function? That's a parabola that's upside down. Could have been the one we drew up there. Find the limit as h approaches 0 of f of x plus h minus f of x. So remember when we were doing limits, we had this occur a couple of times. And f of x plus h means this is getting substituted in for x. So we have the limit as h approaches 0 of, so we have negative x plus h squared, because we're plugging in x plus h for x, minus 4 times x plus h, and then plus 1, minus our original f of x. Now right now, if I let h go to 0, well, I get 0 over 0, and we know that's bad. So that means we have to do something, and we need to simplify. So x plus h squared that's really, so I'm going to come off to the side here. X plus h times x plus h, which is x squared plus 2hx's plus h squared. And if I'm subtracting it, that would give me, let's see, negative x squared minus 2hx minus h squared. Now I need to distribute the negative 4. So negative 4x minus 4h plus 1 minus the original function. So minus negative x squared would be plus x squared plus 4x minus 1. Now let's see if we can do any nice algebra mumbo jumbo. Ooh, I see some nice stuff. Negative x squared plus x squared. Negative 4x plus 4x. Plus 1 minus 1. Nice. So what am I left with? I've got negative 2hx minus h squared minus 4h all over h. All of those have an h in them, so I can divide each term by h. So when I divide that by h, I get negative 2x minus h minus 4. Now we can let h go to 0, and we get negative 2x minus 4. This is considered to be the derivative of this function. This is a rule that'll find the slope at any point on the graph, the slope of the tangent line drawn at any point on the graph. So let's think about what that really means graphically. So we have our f of x, and we found f prime, which is another way of saying the derivative. And what if I plug in negative 4? So I'm going to find f prime of negative 4. So that's negative 2 times negative 4 minus 4. That's 8 minus 4. That gives me a positive 4. So let's look at when x is negative 4. Well, here's my point. What this is telling me is if I draw a tangent line at that point, tangent line means it touches at one point. This says its slope is going to be 4. Let's see if that's true. Up 4 over 1. Backwards. Ooh. That does look like it has a slope of 4. It worked great. So what about at -2? Plugging in -2 into this function, I get 0. So let's look at when x is -2. If I draw a tangent line, it does have a slope of 0. What about at -1? That would be a +2 minus 4. So we get -2. So does it make sense that right here we're going to have a negative slope for a tangent line? Well, yeah, and if I draw in a line with a slope of -2, it definitely is a tangent line. So the value of f prime at certain x values gives us the slope of the tangent line. When x is that value. So the definition of the derivative. The derivative f prime is a function that results from taking the limit as h approaches 0 of f of x plus h minus f of x over that change in x's, which is h. And what does it represent? And that finds the slope of the tangent line drawn to the graph f of x. So could we find the equation of each of those tangent lines? Well, that's easy. If we start off with the point of tangency, and I tend to like to abbreviate the point of tangency, when x is -4, is going to be -4 comma f of -4. So I've got to actually find the y value there, which we can look at the graph. That's 1. And the slope of tangency is f prime of -4, which we found to be 4. Now, how do I write the equation of a line when I have the point and I have the slope? Well, the easiest way to do that is y minus y1 equals m times x minus x1. That is the best way to do it. That finds the equation of line really easy. So y minus y1, slope, x minus x1. Or we could write it this way. Or we could distribute 4x plus, so we'd have 16 plus 1 is 17. What about at negative 2? So the point of tangency, let's see, we have negative 2. We need f of negative 2. So the y value at negative 2 is 5. The slope of tangency is f prime of negative 2, which we found to be 0. So y minus the y value equals the slope times x minus negative 2. Well, that's just 0, so this is just the line y equals 5, which makes sense because it's a horizontal line. Equation of the tangent line at x equals negative 1. Point of tangency, when x is negative 1, we need to find f of negative 1. Look back to the original function. So the y value is 4, and I'm looking at the graph to find those y values. Slope of tangency is f prime of negative 1, which we found to be negative 2. So y minus the y value equals the slope times x minus negative 1. Plus 4, or I could distribute. That'd be negative 2x. That'd be a negative 2 plus 4 is a positive 2. And does that work with the graph we drew? Negative 2x plus 2? Yep. Y equals 5. And I bet if the graph kept going, that 4x plus 17 would be correct for when x is negative 4. So something you want to make sure you know is if you hear the word derivative, I want you to think slope of the tangent line. And if you hear the word slope of the tangent line, you want to think derivative. And we're going to go through that a lot in class. So we're going to do a little practice here on finding this difference quotient, finding the derivative of each of these. So you're welcome to try it, pause the video, try them, and then check your answers. So the first time through, we're going to plug in x plus h. Distribute. Oops, all over h. Ooh, beautiful, beautiful. Love it. The only term left has an h in it. So if I divide right here, I'm going to get 2/3. And that's interesting, isn't it? That the slope on this one is constant. Oh, it's a line. That makes sense. Slope is constant on a line. All right, so we got x plus h squared minus 2 times x plus h plus 3 minus the original function. X plus h squared. We just did that on the other page. I think that was like x squared plus 2hx plus h squared. Distribute the negative 2 plus 3. Distribute the negative 1 here. Oh, I wish there was a shorter way. There will be. Just wait. Distribute the 1/2. Now, did anything divide out already? Hold on, or subtract out. We got a negative 2x and a positive 2x. Positive 3 and a negative 3. That's cool. That saved us some space. Anything else cancel out? Ooh, yep. Now the terms that are left all have an h in them. So I can divide by h. So that would be x plus 1/2 h minus 2. Now I'm going to let h go to 0. So that's going to get rid of that term. So I'm going to have x minus 2. Notice that these are very different. This one's constant, and this one isn't. And that's because on a parabola, as our x changes, so does the slope. So one side of the graph, you'll have positive slope, and one side you'll have negative slope. We're going to do the rest of these in class.